So this is a page from NASA, grc.nasa.gov. So we are here to see what is the uh, value of the tropical year. The tropical year is the year that is what is responsible for the seasons. So basically, this is the calendar. There are other kinds of years that we can define. A sidereal year. Sidereal year is defined with respect to the zodiac or the stars. That the sun starts from, say, Aries and comes back exactly to the same position in Aries. That will be the sidereal year. Or there is anomalistic year, where the sun starts from perihelion. That is the greatest distance from the sun. The Earth starts from the largest distance from the sun, and again comes back to the same point, perihelion. So this is called the anomalistic year. But the year that is the length of the year, period of the year that is responsible for seasons, planting, harvesting, and the weather patterns is the tropical calendar, a tropical year. And this is defined as the year or the length of time between vernal equinox to vernal equinox. And this is about 365.2422 up to 4 decimal places. So if we take higher, it will be 365.242197 or 96. It will be pretty high, very very close to 2. So 365.2422 is the length of the tropical year. So basically, if this is the Earth, this is the equator, this is 23.5 north, this is 23.5 south latitude. So this 23.5 north is in the textbooks and all usually called as Tropic of Cancer. This is a much older 1500 year old nomenclature, because the sun is no more when the sun is at the 23.5 north position. Sun it is no longer in the Cancer zodiac. It has moved to Gemini, and maybe within 400-500 years it will even cross Gemini and move into Taurus. So similarly, the 23.5 south is called Tropic of Capricorn in the textbooks till now. But the sun is no more in Capricorn zodiac when it is in the southernmost position. It will be in it will be in Sagittarius sign, and in another 400-500 years it will leave Sagittarius and move into Scorpio. So basically, whatever the definition that we have with respect to the stars and all, they keep shifting due to the precession of the equinox, and this is also one of the proof of that. So initially in 480, 380, it used to be called Tropic of Cancer, Tropic of Capricorn. Now those nomenclature is no more valid. So it has to be called Tropic of Gemini and Tropic of Sagittarius or something like that. Or call nothing. Don't base anything based on the zodiac sign. So basically, what the tropical year means, it's the north-south movement. It captures the north-south movement of the sun. So the sun keeps oscillating or cycling between this northern limit of 23.5 north and the southern limit of 23.5 south. So basically, on March 21st, this is called the spring equinox or the vernal equinox. Around March 21st, the sun will be exactly over the equator. So if we are at the equator around March 21st and you directly look up towards the zenith, then you will find at 12 o'clock you will exactly find the sun overhead. So it will be like the zero shadow day on the equator. Then the sun moves to, by June 21st, it moves to the topmost position, the northernmost position around June 21st. So if you are around 23.5 north around June 21st and you look up, the sun will be directly overhead. Similarly, this is the autumnal equinox around September 23rd. It will again cross the equator. The sun will again cross the equator, and by December 21st, the sun will be on the southernmost limit, 23.5 south. So if suppose you are in 23.5 north and you look overhead at the on December 21st, you will not find the sun directly overhead. It will be towards the south. Even at 12 o'clock in the afternoon, even though the sun will be exactly on this longitude, but um, it will be not overhead, it will be towards the southern direction. So basically, this cycling is what causes the seasons. This is the summer season, this is the winter season, and so on. So in order to estimate this, so this is not exactly, we saw this is not exactly in synchrony with the zodiacal signs, the movement of the sun around the zodiac. So this is a different definition, that will be a different definition. So this is what is relevant for weather and seasons and all. So in order to capture that, in the first it was estimated to be 360 years, 360 days in very ancient times. Then they improved it to this time period, the cycling between this, say, spring equinox to spring equinox. Then it was later estimated as 365 days. During the times of Julius Caesar, the 365-day calendar was improved to 365.25 days. So there were normally 365 days, and every 4 years there was a 366-day year with one leap day. So that became 365.25. So even that was not enough. It was causing seasonal shifts, because the accurate value is 365.2422. So there was another correction made by Pope Gregory. So this is the Gregorian calendar. So this is the algorithm for the calendar. So most of the years it will be 365 days. Every 4 years there will be a leap year. So every 4 years leap year means all the centuries will also be leap years. But in order to reduce this from 365.25, we leave the leap day only at the 400, only when the century is divisible by 400, and rest of the centuries which are not divisible by 400, the leap day is removed. They'll have only 365 days. So basically, say 1200, so 1200 AD, it's divisible by 400, so that will be a leap year. But 1100 AD, which is not divisible by 400, will have a normal 365 day year, no leap year, even though it is divisible by 4. Then 1300 also is not divisible by 400. So 1300 AD, even though it is divisible by 4, will also have 365 days, not this leap year. So this is the algorithm for generating the Gregorian calendar. So and over the long term, it will have an accuracy of 365.2425. So even this is not exactly 365.2422. There will be a slight error. So now this is the improved tropical calendar. So where we'll get exactly 365.2422. So normally all the years will have 365 days, and the second step is also same, the leap day. Every 4 years there will be a leap day or 366-day year. Now instead of testing for whether the year is divisible by 100 or 400, what we check is, we'll just check whether the year is divisible by 125. If the year is divisible by 125, we remove 1 day. So for example, this will just have 364 days. So here, say February has 28 days, here February has 29 days. Then in the third step, every 125 years, we'll have a February only 27 days, or something like that. I mean, we'll have to remove 1 day. We can remove from anywhere. We'll have to check, but it will have overall 364 days per year. So this is 365 days in general. Every 4 years 366, and every 125 years only 364. So we're not checking for whether it's divisible by 100 or 400, things like that. So we'll have to check only two things, whether it's divisible by 4 or whether it's divisible by 125. So in a sense, it's a slightly simpler algorithm than this. We'll have to check only these kinds of only divisibility by 4 and 125. Here we have to check divisible by 4, divisible by 100, and divisible by 400. And this gives this value of exact 365.2422, which is exactly up to 4 decimal places. This is the exact value. So if we want to increase, then we'll have to do corrections over lakhs of years, or like say 2.5 lakh year or something, because this will be 365.242197 or 96, something like that. So for about lakhs of years, this calendar is good enough. improved tropical calendar. uh, uh, unless we have to include other over lakhs of years, obviously there will be much more corrections that will come. But regarding the precision of the equinox and the tropical year, uh, even over 4,000 years, this will be 4 5,000 years, 10,000 years, this will be a little more accurate than the Gregorian tropical calendar. So, okay, this is the improved tropical calendar, Gregorian calendar. So, in the improved tropical calendar, in 5,000 years, there will be exactly 18,26,211 days. And in the same time, in these many number of days, uh, this will have 1.5 days less than 5,000 years. So basically, if we start from 0 AD and go up to 5001th year, the 1st January 12 a.m. Middle of the night, 1st January, just the day switching over to 1st January 5001 AD. If that is what the time that is shown, date that is shown in this calendar will be 1.5 days behind. So it will be reading December 30 midday 4999 AD, or 5000 AD, 1.5 days less, or December 30 midday. This will be on January 1st, already on the next year, over 5000 years. So here I forgot to mention one point. So if a year is divisible by both 4 and 125, so every 4 years we have to add, every 125 years we have to remove. So if it's divisible by 4 and 125, the addition and deletion both are applied, and we will have a normal 365-day year. So for example, AD 500 or 500 AD will be divisible by both 4 and 125, and it will have a 365-day, because it will have one leap day will be added because it's divisible by 4, and one day will be removed because it's divisible by 125. So overall effect, it will have 365-day year.